Hello everyone, this is my next video. Today I am going to explain Leetcode question number 94, binary tree in-order traversal. Given the root of a binary tree, return the in-order traversal of its nodes values. In the example 1, they given root 1 with left is null and root is 2, and the root 2 as this is a right subtree and it as left 3 and right as null. Okay, in the inputs you can observe briefly they given 1 null 2 3. Okay, and output they are returning 1 3 2. In order traversal means we need to traverse first left, then root, then right. Let's briefly understand in the whiteboard how it's going to work in order traversal. We can take this example how in order traversal will going to work. A B order means first left, then root, then it right. It will traverse. Okay. See here, root means we are traversing from D to B, then we'll come to E, then we'll go to A, then we'll come to F, then C, then G. This is in order traversal. How it is going to traverse means D, B, E, then A, then F, C, G. Left, root, right. See, this is one left subtree, okay? It will traverse first. Then it will print this root A, then right subtree. First F, C, G. This is in order traversal. How it is going to work like this, okay? We can understand the logic how it is going to work. Starts with root. We are passing this root as 1. Okay. We will check. The root is null. See, root is not null. So this if condition will not execute. Now what we will do? We will traverse in order root left. Root left is 2. Okay. Now our root will be this 2. Okay. See, now root left is 4. Okay. Now our this subroot will be a main root. Now it will be 4. Okay. Now we'll check the root value. Root left. Its root left is null. Okay. If it is null means we will come back. Okay. Now we traverse it left. Now it's time to print root. Now this one completed. Now this will execute. Now 4 we will it will be stored in this vector. Okay. Now we will traverse in order root right. Root right is null. We will come back. Now see left root right has been completed. Okay. Now we'll go back to this 2. Now this left root has been completed. Okay. Now it's time to print this 2. This left has been completed. Now we are pushing this root. So we are going back. Now see left has completed, root has completed, right has completed. Total these 3 has been completed. Okay. This 1 is called upon this left subtree. Now we are printing this 1. This left has been totally completed. Okay. Now we are printing this 1. After that we are traversing root right. Now we are traversing this root. Okay. Now we are traversing this right subtree. Okay. Now we are passing this 3 as root. Okay. See this 3 is not equal to null. So this if condition will not execute. Now we are traversing in order root left. The root left is 5. Okay. Now our root will be 5. Now we are calling upon this function. Okay. Now we are recursively calling on this 5. Okay. See root left. This root left is null. So we are going back to this 5 and this has been completed. Now we are printing this 5. This root we are printed. Okay. Now this 2 has been completed. Now we are traversing in order root right. The root right is null. We are going back to this 5. Now see left root right has been completed. Now we are going back to this 3 and we are printing. Now as for left and root has been completed. Now we are traversing right. Okay, this 6. Now passing this 6 as root. Okay. Now we are checking the root left. This root left is null. Now we're going back to this 6 and we are printing. Left root node has been completed. Now root has been printed. Now we are traversing in order root right. Here root right is null. Okay, we are going back to this root. See, left, root, right has been called by this tree node. Okay, this node has been called by this root. Now we are going back to this tree, and here left, root, right has been completed. Now we're going back to this one. See, total left subtree we printed, and then root, then right subtree. Traversal has been completed. Okay, this is the logic by using the in-order traversal. We can enter into the coding part. First, we're creating empty vector of integer type with VEC name. We are taking in-order function. We are passing the root and VEC. Finally, we are returning VEC after traversal completed. Now we are creating void in-ordered function. We are passing the parameters tree node of root type, and we are creating vector of integer with reference of EEC. That we are checking the root node is null or not. If it is a null means we are returning. We are going back. We are traversing left, root, right. So in order, here we pass two parameters, root and VEC. We are traversing root left and vector. We are pushing the on vector, okay? So VEC. After that, we are pushing. This is a root. We are pushing the by using the pushback function. We are pushing the root value. We are recursively calling the left subtree. In order, root, right, VEC. This is the logic of code by using the recursive approach. Okay, how it is going to work? Let's pick and dry run. How it is going to work? Let's pick and dry run. First, we're passing this root 1. Okay, we will be creating vector to store all the result. Okay, we will checking the root is null or not. Yeah, this is root is not null, so we are not returning anything. So we are traversing root left VC. This root left VC is 2. Now we are passing this 2 in this root. Okay, now we are checking the root is null or not. Yeah, it is not null, so we are traversing left subtree. Okay, root left, its root left is 4. Now we are passing this 4 as root. Now we are checking this 4 is null. No, then we are traversing root left, its root left is null. Okay, then we are checking the root is null, so we are returning back. We are going back to this 4, and we are now we are pushing in the vector. Okay, now see, left root has been completed. Now it's time to traverse right. Now right subtree is also null, so we are going back. Now see, left root right has been completed. Now we're going back to this 2. Now total this left has been completed. Now it's time to push this vector. Okay, this 2 will be stored in this vector. Now left node and root has been completed. Now we are traversing right. Okay, now our root will be 5. 5 is null? No. So now we are traversing root left of 5. This 5 root left is null. Okay, we are going back. Now left has completed. Now root. Root 5 will be pushed in the vector. Now we are traversing right. See, right subtree is null. We are going back to this 5. Now see, left root right has been completed. Now going back to this 2. See, left node root and right has been completed by called upon this 1. Okay, now we're going back to this 1 and we're printing this 1. Now this left and this root value has been completed. This left and this root. Now we are traversing right subtree. Here right subtree is 3. Now our root will become 3. Okay, we are checking now. 3 is null or not? Yeah, it is not null. So we are going traverse left. Its left is null. So we're going back to this 3. Now left has been completed. Now root. Now we are pushing the root in this vector. Now these two statement has been completed. Now we're traversing right. Right subtree is null. So we're going back. See now left root right has been completed. Okay, now we're going back to this one. Left node root right node has been traversed. So all nodes have been stored in this vector. This is the logic of traversing by using in-order traversal. Okay, we can understand the time complexity and space complexity of this logic. Here n is the number of nodes in the binary tree. We are using here The time complexity is big of n, where n is the number of nodes in the binary tree. We are traversing every node exactly once. So it is taking the time of big of n. Where comes to the space complexity, it is taking big of n. Here we are creating vector to store all the nodes, and every node we are calling the function in order. So it takes the one space for all the nodes. There are n nodes means it is taking the n space. So it is taking big of n. Overall, it is taking big of 2n, where 2 is a constant, so it takes the space of big of n. This is the approach by using recursive. Next, we can run the code now. Yeah, this is accepted. Let's we can understand how it is going to work by iterative approach. In iterative approach, first we are creating stack. In order means left, then root, then right. First we will store the left node in the stack. Okay. When it reaches to the null, we are taking the top node and we are popping out and we are storing in the vector. First we will store root in the stack. Then its recursive left will be B. Then its left is D. Then we are storing this D in a stack. D's left is null. When it is reaches null, we are taking this D, we're popping out and we are storing in the vector. This and see left has been completed, root has been printed. Now we are traversing right. A right is also null. Now this will be the top of stack. That B will be popped out and we are storing in the vector. Now left has been completed, root has been completed. Now we are traversing right. Now E will be stored in this stack. Now we are recursively calling the left. This is null. Okay. Then we are going back. Okay. If it is null means we are popping out of this E and we are storing in the vector. Now left has been completed, root has been completed. Now we are traversing right. Here right is null. Then our top element is A. Okay, we are popping out this A, we are storing in the vector. Now left has been completed, root has been completed, right. Now we are storing left node has been completed. Nothing but this is a left subtree. Now root has been completed. Now we are traversing recursively on right. Now C. This C will be pushed on the stack. This left is F. Now we'll store F. Okay. Now we are recursively calling this F as left null. We are going back. Okay. Now if it is reaches to null means we are popping out this F from stack and we are storing in the vector. Now F right is null. If it is a null means the top element is your C. We are popping out this C. We are storing in the vector. Now left has been completed. Root has been completed. Now we are traversing right. Now G will be stored on the stack. G's left is null. We are going back. Now we are printing this G because this G will be popped out from the stack. We are be stored in the vector. Now G's right is null. G's right is null. Okay. Now see the current node is G. This is null and stack is empty. If any one condition is true means we are traversing. If both conditions are been false means now we will come out of the condition. Now will be printing this vector. Okay. This is the logic by using the iterative approach. Let's we can enter into the coding part. First, we are creating empty vector. It is integer type with name VEC. Then we creating stack in iterative approach. So we are creating stack. It is a tree node type with the name ST. Tree node will be pointing. Okay. We will be storing the root in the current. Okay. First, we created tree node with current. We will be stored the root value in the current. Now checking the condition, the current should be not equals to null and the stack should be not empty. If any one condition is true means it will satisfy. Again in this while loop we are checking the current should be not equals to null. If the condition is true means what we are doing, we are pushing the current in stack. After that we are traversing the left. If the current is node is null means what we are doing, we are popping out. Okay. After that we are storing in the vector. After that, we are recursively calling the right. Once after completing traversing, when the condition become current is equal to null and stack become empty, we are returning our vector. This is the logic by using iterative approach. Let's we can run the code. Yeah, this is accepted. Now we can dry run the code. First, we have created vector of integer VEC. Okay, we will store in the vector. We will be creating one stack to store these values. Okay. The root value will be stored in current. Okay, now starting 2. This 2 will be stored in the current. If it is not equals to null means, yeah, 2 is not equals to null. So we are pushing in this stack. Now we are checking the current should be equals to current left. Yeah, this is 4. Now 4 is not equals to null. Yeah, this condition is true. Now we are pushing onto the stack. This 4. Now current is equals to current left. Now current left is 8. Now we are checking. 8 is not equals to null. Yeah. So we are pushing on to the stack. Now we are traversing 8's left is null. When it reaches null, what we are doing? We are popping out the current node. It is a top element of the stack. Okay. We will be popped out and we are pushing on the vector. See, this 8 will be popped and we will be stored in the stack. It is the top element of the stack. Now current we are recursively traversing right. It's current equals to current right means 8. This is null. If it is null means the top value will be stored in the current. We are popping out this. The top element is 4. Okay. Now we are popping out. We will be storing in the vector. Now left node has been completed. Now root. We are traversing right. Here 10. Now we'll check the condition. 10 is not equals to null. Yeah. So we are pushed the 10 into the stack. Now we are traversing left. Its left is null. Yeah. If it is null means the top element will be popped out. Okay. This top element is 10. This will be popped out and will be stored in the vector. Now we are traversing right side. The right side is null. If it is null means we will be popping out. See, this 10 has been popped already. Now it's time to pop out this 2 and will be stored in the vector result. Now see, this left subtree have been be traversed. Root also traversed. Now we are traversing the right. Current of current right is 6. Now 6 will be stored onto the stack because 6 is not equals to null and we are pushing onto the stack. Now we are traversing current of left. The current of left is null. If it is a null means the top element is popped out and will be stored in the vector. This 6 will be popped out and will be stored in this vector. Now we are checking the right. The right is null means current node is null and stack is empty. If both conditions are not satisfying means we will come out of this while loop we are returning vector. The vector is we are returning 8, 4, 10 to 6 as answer. This is the logic by using the iterative approach. Now time to understand the time complexity and space complexity of this logic. The time complexity is taking big of n, where n is the number of nodes in the binary tree and we are using while loop. We will traverse each node exactly once. So it is the taking the time of big of n. Where it comes to the space complexity, it is taking big of n because we are creating a vector to store all the nodes. So it takes space of big of n. Thank you guys for watching my video. If you like this video, please like,